Okay, I don't listen to you finally your explanation, Gemma, but if you I don't know if you have finished. I suppose yes. Gemma, have you finished your first question? Okay.
Yes,
So,
I finished answering my first question.
Okay, I would like to come back to you. Okay, regarding a simple question about technology. Blockchain technology mature enough to really be implemented and make big scalable with big scale projects in these processes in the industry? What is your opinion now?
I'm not sure I understood your question properly, Felipe.
Yes, I'm talking about your consideration regarding technology maturity. Sometimes, some years ago, blockchain could be, good for making pilots. It's a common sense in many is that it's good for making pilots, but it's not really implemented in big scale projects. Okay, because an early technology. Do you think that now we are in a technology level that will allow to make big scale projects in the companies?
Yeah, I think that there'll be a much greater level of scale possible now, and I think that there's been enough proof points from trials and proof of concept deployments to validate the technology to a certain level of scale. But I think that the actual proof points around large scale will need to be evidence, and I think they will be. We have a number of commercial contracts now that we're rolling out our technology for at a much larger scale than we have done previously, and from what I see from other players in the electricity and energy sector, similar things are occurring, which is like natural, I guess, in terms of the maturation of the sector.
Okay, Sabine, when you mentioned your different initiatives in Shell, okay, one of the main areas of blockchain is to create conditions, okay, of collaboration between different companies, okay, and in the oil and gas business, collaboration is a must in some parts of the value chain, okay, example of joint ventures management, okay. Can you give us some use cases that you are developing in your company regarding collaboration and how you use blockchain to create an ecosystem of collaboration between different parties?
Sure. I think, when we started out this journey a number of years ago, we very quickly realized, as many, of course, did in this space, is that you need a whole collaboration and a whole team and a whole industry actually to come along with you. Blockchain is not about winning by yourself. It's not about being the first to the chase. Blockchain is really a team sport, right? So you need to bring your peers, you need to bring your customers along with you in that journey. And by having realized this actually quite earlier on in our blockchain journey within Shell, we have made different collaborations in the industry to ensure that we move forward as a whole industry and not just individually. One of those examples, as Christopher's already also mentioned, is the Energy Web Foundation. So Shell is a founding member of this foundation. Really has it started, 10 big energy companies coming together, and all with the common goal of, we need to decarbonize the energy sector. We see blockchain as a high potential technology that can help us do that. And, interestingly, it was first 10 companies. But after that, now it has grown out to such an interesting ecosystem of more than 120 or 130, I think, affiliates, where you're interacting and collaborating with startups, big companies, financial players, etc. And you're all bringing those different parties around the table with one common goal. And that, I think, is a really interesting first example where we see for especially the renewable energy sector and sustainability a key foundation that helps us accelerate that transition. Maybe just a whole different other example as well. I think within the energy sector in general, there's a lot of efficiency to be gained from bringing collaborations together and using blockchain to exchange information between companies. One example, we've just rolled out a pilot at one of the sites with 5 different partners, all around supply chain traceability. And the example that Christoph used around, having a passport, and only with a passport you can travel, we've actually implemented that on equipment throughout Shell. So equipment for it to travel throughout its life cycle, it needs a passport, how it's exchanged between all these different companies. So that's just from a different perspective, another collaboration where you bring together parties that we've always worked with, but we've said, we can do these kind of processes in a completely different way that actually adds value to every single business. And that's maybe just 2 of the examples that I'd like to highlight here on new collaborations that have started out and have all brought us together for this common purpose.
Okay, thank you very much, Sabine. Christoph, when you talk about assets, okay, the passports and how this technology can help to really integrate assets with their identity into the collaboration. Can you give us some examples in the power sector that you are collaborating with in these topics?
Yeah, there's 2 examples that I like particularly, and perhaps also link it back to your question about scale. One, to talk about one example where APG, the Austrian power grid company, has given itself the ambition to bring 1 million stationary batteries into the system as part of the overall system storage. And again, those batteries do not belong to APG. You need I think the collaborative aspect to work with other parties to bring those in is very important. And blockchain, what does it? Again, it gives, first of all, the passport to those batteries, so you know exactly which battery has what data set behind it, and that's very important. You need to bring battery into a system. You need to know what is the load status of batteries. Otherwise, as a system operator, there is nothing you can do. And I think this is one example where through blockchain you can you link it with other technologies, you give an identity to the individual batteries, you work with other parties to do so, and then you link data such as the status data, load status data to those identities, and that gives a system operator the possibility to use those batteries then as an Internet of Things type of aggregate battery. And there is not only APG, there is ELIA, 50 Hertz, many other TSOs working on things like that, and that's certainly one exciting use case where that identity is important. The other one is traceability. Again, if you want to be sure that when you are sell renewable energy, or as a buyer, when you buy renewable energy, if you want to be sure that the renewable energy that you bought has been sold only once, it's very important that the unit of renewable energy has its own identity, or the point of production of that renewable energy has a clear identity, and you cannot in multiple ways sell that. And again, that's another killer application of blockchain here, where you see companies such as Singapore Power, Engie, many more companies using that. It's the large oil and gas companies use it for tracing of is it CO2, is it greener fuels like biofuels, is it renewable energies, and we see that obviously as a very important collaborative aspect where blockchain plays a role, again, in providing those identities.
Okay, thank you, Willy. Thank you, Christoph. Now, well, I will open a question for the 3 of you. Okay, one of the parts of the value chain we have been talking about is the consumer. Okay, and how blockchain can apply to the consumer. There are many examples related, by example, to economy. Economy that where the consumer is participating, okay, like peer-to-peer and trading for distributed generation, or electric vehicle, or charging, or sharing, okay, management with blockchain. But would like for the free to give us some examples where you are applying blockchain technology for the consumer, okay, for involving the consumer into this blockchain collaboration ecosystem. Okay, so I don't know, Jemma, do you want to start with the answer? Jemma?
Felipe, you just cut out for like a second, so I couldn't hear like 5 seconds of what you said.
Sorry, maybe it's another communication problem of myself. I was making a question regarding where you see opportunities or examples where you are implementing blockchain technology for managing customers. Okay, I gave some introduction regarding sharing economy where blockchain is being used, okay, for involving the consumer into the value chain, okay, like peer-to-peer energy trading with distributed generation assets, or electric vehicles recharge, or electric vehicle saving, okay, are examples where blockchain is being used. But I would like to listen from you examples where you are using this technology related to the consumers.
So I think that virtual. Thank you. I think virtual power plants are like a very interesting use case where households that have batteries, the primary use might be to supply their own needs, but a secondary or tertiary opportunity may be around them arbitraging the spot price in the wholesale electricity market, or providing frequency control, our ancillary services, grid stabilization, or also dealing with congestion as well. So taking electricity and storing it in the battery in a discrete part of the grid that has too much electricity at a particular time of day. And like in Germany, there have been some flexibilities trials already, and the energy communities legislation from the EU, I think, is really promoting households to set up their own energy communities, and also to become more active participants in electricity markets. And to be able to do that, they obviously need to understand what their system is capable of, to know what the charge state is, to know what the need state is of the market, and have something that will automatically manage all of that very simply and elegantly for them. And in the case of households, it's likely that sort of a step for their direct participation into the market will be via aggregators. So there'll be a need for aggregators to step in, and they will need software that will automate the process by which consumers can participate in the wholesale electricity markets via the aggregator. So to understand what the charge state is, and then to coordinate and orchestrate the dispatch of things like batteries for various energy and ancillary services and flexibility services. So these are very complicated functions. It's not like somebody's going to be manually turning on and off, their pool pump or their air conditioner. There is an absolute need for automation for this to occur, not least because the households are not going to do it if it's required for them to manually do that, but the reliability won't be there for the system. And looking at a non-network solution, you need to have confidence in its ability to deliver. Otherwise, what will happen is you'll try using non-network solutions from household batteries or commercial industrial batteries for that matter. And if they're not reliable, then a network solution is also required. And so this to be firm and reliable to go down that path in the first place. And I think automation is essential for the establishment of confidence in the market, for the market to grow. And at the moment, I think there's a lot of talk about this happening, but there's a nervousness around, can we rely on it? Can we count on it? And I think blockchain is important for counting the actual transactions, but also providing that information for a lot of small participants to aggregate that information in a transparent way so that it can be tracked and traced and to assist in building the confidence that's needed for the establishment of this kind of market activity. So I think that there are a lot of pieces that need to kind of assemble for it to not just be discrete projects happening, even discrete ones at scale, but for widespread adoption. But I think this is a very meaningful and exciting use case for blockchain, and that will engage consumers, business customers, and commercial and industrial customers alike.
Okay, thank you very much, Jemma. I really like the use case regarding the energy communities. Okay, energy communities is a push now for the European regulation. Blockchain can really help to really create that confidence and the need, how the consumers can, or prosumers can participate in that energy community. It's really a technology that can help on that. Sabine, maybe leaving energy communities, looking for another example that you can bring regarding the consumers.
Yes, and a really great examples, Jemma, that you've just shared. Maybe just to build on with a couple, I think, everything when we're going through this energy transition, the consumer needs to be central in all of this, which is very important. And I think, two main levers with blockchain, what it shares with consumers or enables consumers is, first of all, to be more in control. I think that is one element. And second of all, to add on to what Jemma just mentioned, is to allow to actually participate in local energy grids or local energy communities. And I think those are the two key elements where I see around blockchain, around customers being central in this and what kind of value this ultimately brings. I think maybe just to hover and take a bit of a step back, one of the main things about being more in control and being able to participate with your energy assets as a consumer, I think, the common thread for how I see it is really getting that guarantee of also where energy comes from that you procure, and really providing consumers more guarantee on how are the attributes of this energy green, or what was actually, how did this come to my household, or for example, for a transport sector, if that's going to be using green hydrogen in future, how do consumers that could be big customers, big businesses, but also individual consumers know that is coming from truly sustainable sources? Just looking back to that example, I think that is an absolutely key enabler to what we're doing here with blockchain throughout the whole energy industry, both on the electrification, but also in other low carbon fuel solutions. Really that core attribute of with blockchain, creating that digital representation and sharing attributes of that energy and allowing consumers to be guaranteed of where that energy comes from. I think that's an absolutely critical, and that will, at the end of the day, enable all different kinds of new creative solutions on how to decarbonize communities and sectors on a large scale, which I think is a very exciting topic. Maybe last one example, and that's also close to what Jemma just mentioned, is around Shell Ventures, and the new energies arm of Shell has invested in a company called LO3 Energy based out of the US, and there they've done a similar concept of really building out peer-to-peer enablement and participation in energy grids, which I think is a very clear example as well of live projects around the world where they have been able to deploy these technologies for really to allow consumers to participate in these energy grids.
Okay, thank you very much, Sabine. I really liked your how you use the traceability characteristic of blockchain for the certification of the being of the energy. Okay, it's really something very valuable for helping decarbonization. Okay, it's really good. Christophe, I don't know if you have another example that you can share with us regarding the using in the blockchain with the consumer.
Well, thanks, Felipe. I think Sabina and Jemma have given great examples, and perhaps it's I'd rather at this stage try and group those in what I think are three fundamental values to the customer. And the first one is, again, and that's the traceability example that you have just highlighted. The first one is that the consumer has a way of better knowing what he is buying, simply by trusting, by having direct access to a much more trustworthy information through the blockchain, for typically green or otherwise labeled goods. So the first one is this kind of increased trust. The second piece, and I think there's examples, are for the consumer to be able to have own assets becoming part of the system, and that's something today that there's only very limited possibility, but blockchain does allow that and allow for that. And the storage, the battery could be an example. You can even go as far as thinking of your fridge becoming part of the system by making it on and off switchable, and that's obviously true for other assets too. So having own assets that become part of an overall system and thereby gain a tiny margin, I think is a second benefit. But then the third benefit, and I think it's the third benefit that is really very, very important, is this self-sovereign identity management. And if you think of the cell phone today as an example, your cell phone has an identity, but that identity belongs actually to the company, the cell phone company who provides you with the service. The blockchain does something entirely different. It does give you the identity, and it's for you then to be in control of that identity. If you want to switch from one to another provider, that's much easier. And I think the example of the EV charging, you go from one supplier to another with your identity, and the billing is linked to that, is just one example of that. So those three are the categories that I think are critical for the consumer: the traceability and trust, the capability of bringing own assets into the system, and third is sovereign identity management, which allows you to move around in the system in a much more effective way.
Okay, thank you very much, Christoph. You have made a very, very good summary of how to apply the blockchain technology to the customer. Okay, so I would like now to change of another area in the supply chain. Okay, some of you have been talking about markets. Okay, energy markets. Some of you were talking about storage market and the involvement of the batteries into the market. All of you have been talking about the renewables, okay, and how to involve the renewables into the market, or how to make energy transactions between different parties into the markets. So I would like to listen from you areas or examples where you are working regarding energy trading, okay, and settlement of the energy trading, and how you are applying blockchain to this part of the energy value chain. Okay, I don't know who wants to start. Maybe Jemma, it's okay for you, or Sabine, who would like? Jemma, can you give us some examples?
After you, Sabine.
Okay,
I'll go second
right.
this time.
All right, let's switch it around a little bit, the order. Happy to start. So, maybe one of the most progressed examples I just want to give here around the energy trading and post-trade settlements. Shell is a founder of a venture called Fact. And this is a venture that was established already a number of years ago, 2018, I believe, if I got that correctly. And this is really a joint venture with a number of different companies that was fully led by the Shell Trading organization, and they're completely focused on the post-trade settlements process, a process that has previously been quite manual. There was a lot of reconciliation between all these different type of companies, including trading houses, energy providers, etc. But there was so much exchange back and forth between these companies on information, which just could have been done in a much more efficient way between these companies. So Fact is an early venture that was set out to build a streamlined blockchain-enabled system that allows for a much more efficient post-trade settlements platform. So it's not the trading aspect itself, it's mostly post-trade settlements platform. And that has now grown out to a company that provides these services within Shell and the energy industry as a whole. So maybe that's the most concrete one on a larger scale that I can provide here as a post-trade settlements platform specifically. I think when we're looking at in future, and especially with the electricity market in general, I would imagine a world though where we're not where we're linking those digital passports of those energy assets, and you allow for consumers to participate in these markets, and the trading, the negotiation, the flexibility, as well as the settlement is done all through these digital identities of these passports in these digital assets that participate in the electricity. Is a future, it has a lot of potential of where we're going. And I think then passing it on to Jemma, I think you already have very concrete examples that you can share in that space that I'm aware of.
Sure, thank you.
Thank you.
In France, we're working with a retailer called Equateur to allow some of their customers to choose their own energy mix. So rather than just specifying I get a renewable tariff, they're able to say, I would like solar from this farm, wind from that farm, and our system will measure the output of an asset that generates electricity against the consumption profile of a consumer, and acquit that within an interval, within a 30-minute interval, for example. And so what that does is move from generic renewable energy from somewhere, even perhaps at some time, if it's coming from a renewable energy certificate, to actually being more specific and granular. And in doing so, support local renewable energy when and where it's needed. So it's not just about tracking the provenance of energy generation assets against consumption. It's actually also about putting a price signal to the market to say, at 7 p.m. on Thursday, I need a lot of renewable energy and I'd like it in my local area. And so that may underpin the business case for the installation of things like a biogas plant to provide differential power. So I think that corporate sustainability leaders are now having greater expectations placed upon them from the public and also from their peers to be more specific and granular, and companies like Google that have really set the tone around procurement of renewable energy from power purchase agreements and trying to move towards 24-hour renewable power and publishing quite a lot of data on that, really changing the discourse around what it means to actually be renewable, and that not all renewable energy tariffs are created equal. And I think that the corporate and sustainability leaders are driving greater expectations, not dissimilar way to what happened in the 90s with sneakers, where Nike started offshoring its sneaker production and thought that nobody would care, but its customers said otherwise, and that sort of sparked the expectations of Nike and other manufacturers around the provenance of their manufacturing of fast moving things like clothing and shoes and whatnot. And I think with renewable energy, we've all been talking about it for so long, there's kind of an expectation that we just have it, and people might be surprised perhaps if they start looking under the hood of what's in their energy. So I think the tracking piece is really important, but it's not just that. It actually starts to move towards this sort of 24-hour renewable energy paradigm, and to put price signals in the market when and where they're needed, rather than build lots of energy in the north of Germany when it's needed in the south, and then have a lot of transmission lines that are very costly, and see in some respects places like Germany are the poster child for renewables, but it's actually according to McKinsey, who published a report called Energy at a Crossroads, it said that it was struggling across carbon, energy system stability, and price dimensions. So I think that technology can actually engage consumers and provide more choice and allow the leaders to set the tone, are going to ultimately pull energy that is more low cost and more low carbon, and generate a more stable system in doing so.
Okay, thank you very much, Gemma. Christoph, any types of samples of energy trading or emissions or ancillary service trading that you can bring to the table?
Well, I think it's important just to think of the blockchain, not as the one technology can do that can do it all. I think what is important is that the blockchain technology is one that can extremely well work with other existing technologies. And again, if the trading itself, is enhanced by bringing more assets into the trading system, then that's really the biggest contribution of the blockchain itself. And I think we all have, all the three of us have given already examples of that. The one, again, I think where this clearly wasn't possible in the same way that I've mentioned before, perhaps, is and that is alive today, is the renewable energy certificate trading that has been built, for instance, by Singapore Power. They have built this purely on a blockchain basis. They have had the intention and objective to make sure that they can use that as a way of enabling regional, so beyond national, renewable energy certificate trading, and I think they're making very good progress with that. So it's really, I think, blockchain. We shouldn't think of it as the technology solution that can all do it by itself, but blockchain is an extremely effective technology that can work with other technologies to then enhance opportunities in overall system, and that's true for trading as well.
Okay, thank you very much. I would like to get another view on examples in other parts of the value chain. Okay, we have been talking about consumers, we have been talking about energy management, trading. Okay, but it's true that blockchain in many parts of your own of the clients in other parts, like managing suppliers or like managing loyalties or incentives. There are many other areas of the value chain where blockchain can be used. I would like to, maybe Christoph, you were the last one, so you will be the first now. Okay, can give some other examples where blockchain can be used. Okay, that not only the consumer, not only the energy trade. So Christoph.
Yeah, now I have to pause a moment. I think, you put me on the spot with other example. I tried to give you the best examples that we can think of. I think there's so many more examples, but the question is today, I think, where do we have the biggest use case? Where, and how can we, how can you make sure that that those use cases are really becoming reality? I would bring it back again. What are the biggest challenges that we need to solve? And if in the energy transformation context, we say it's, well, first of all, bringing renewables in, decarbonizing and bringing renewables in. That comes hand in hand with intermittence. And I think so. The biggest element to solve is bringing flexibility into a system on the one hand, and I think again that is a very important part. That's the most important part, and I do believe that the industry is very, very strongly focused on that side. So the Internet of Things aspects, and you can expand that to all kinds of areas. Is that bringing again new passive elements, consuming side, demand side elements into the system? Is that system services, auxiliary services type of elements that can be brought in? Is that storage elements? Is that certification types of elements? I think there's a whole range that can be adding to that, but the biggest part to bring more flexibility, enable sector coupling, enable decentralized assets to become part of a system that works in conjunction. I think that's really the space where we are most focused in looking for use cases.
Okay, thank you very much. Sabine, do you want to give some other examples in other part of your company that you are using blockchain?
Sure. Yeah, maybe just before I go to a couple of more examples, one thing that maybe just would like to stress that I'm not sure if we've put enough emphasis on yet. We talked about quite a lot of the solutions and what blockchain brings in terms of the capability. But I think what everyone should fundamentally understand, and I know the audience is very energy focused here, so I hope they are, but just to reiterate it, I think what's really important is, one of the points that Jemma mentioned, we all just expect renewable energy to be easily produced and supplied around the world with no challenges, right? We almost expect that you have wind farms and solar panels, being able to produce that energy at all times, but these are intermittent sources, right? These are sources that do not provide constant production of energy to meet the constant or fluctuating demand of energy around the world. And I think that together with the increasing amount of distributed energy resources that are joining the grid that we've spoken about at length today, with the energy sector going from a more centralized to a decentralized and distributed network, it makes sense that you need a coordination mechanism that can manage these assets at a large scale. And it makes sense that it's possible that centralized companies or centralized coordination mechanisms will have a hard time to manage all these large intermittent sources at a large scale. So there, I really, really see blockchain adding that value. And I just wanted to iterate that the problem around this, why do we need a facilitating technology, decentralized technology like blockchain, just to make sure that everyone understands that clearly. And then something totally different. You asked for something in different areas of the supply chain or value chain of Shell examples. Shell's working and exploring quite closely around proving the effectiveness and origin of nature-based solutions, where you actually look at the carbon capture and avoided emissions concept, and that offering of making sure that those kind of credits would not be spent twice. And I think that is a very important element to when, after reducing, avoiding emissions, companies will need these kind of mechanisms to decrease their emissions. It is absolutely important to ensure that any carbon credit that represents this nature-based solution is not spent twice, and that you can be assured of the guarantee of that origin. So that's maybe something different type of use case that I'd like to bring in here, which I think is an absolute enabler for us in this decarbonization journey. Another one I would say is if we're looking at heavy-duty transport sectors, just to go into a different spectrum of the energy sector that is hard to potentially use electricity to cover large distances or heavy-duty transport. I think it's absolutely important that you provide these kind of companies and consumers at the end of the day a possibility and a verifiable way to decarbonize. And what Shell's exploring is, can we create or build solutions that provide the authenticity and attributes to ensure that those kind of low carbon sustainable fuels allow these sectors to decarbonize over time, and allow the chief sustainability officers of these companies that Jemma also referred to previously to be 100% sure and guarantee that they are decarbonizing through their scope 1, scope 2, or scope 3 emissions. And there I see a huge enabler for blockchain to provide that traceability and transparency to offer those kind of solutions.
Okay, thank you very much, Sabine. Jemma, can you give some other examples, please?
Yeah, I mean, there's a lot of problems in electricity markets, and I think that's a great starting point. Sabine mentioned, it's not just for the fun of it that these things are being trialed. It's not like everything's perfect and we're, just trying to, refine things around the edges. There's like a fundamental challenge going on around, the need for stable electricity, for low cost energy, for clean energy. And any country that's trying to grow renewables, if you've got a small amount of it in your system, it's not going to cause problems. But once you start getting up to 20%, if you're not growing it in a sensible way, it is going to cause issues around, voltage and reactive power and electricity, grid stability. You're going to need to augment your network. You're going to need to implement sort of strategies to stabilize the grid, which are very costly. So, where there's ambition to grow renewables, some of the mistakes of the past is, if you do it entirely via subsidy models, one, it's costly, and two is you don't always get the right outcome from the physical grid perspective, and it's more costly at the taxpayer level, but then if it's subsidized, but then also the energy system isn't a very efficient one. And I think the proposition around blockchain is around how to grow renewables in a scalable way without the need for subsidy. For countries that have ambitions to grow renewables from a small level to a large level, or those that are actually tackling some of the issues that I just mentioned, for their next phase, using market mechanisms instead of subsidies, and putting price signals in the market using efficient ways of connecting lots of small users to the market, I think really, it's a perfect use case for the blockchain. And I think the other point Sabine made, I echo, around environmental commodities and wanting to validate, one, that it is a true representation of the environmental attributes of a particular type of energy, or could even be that this kind of provenance tracking is used for hydrogen that originates from renewable sources, so you'd want to validate that. And that if you are actually claiming some attribute and utilising that, then it's retired, and that it's not double counted, and that it's easy to trade and settle with the counterparties. And I think that trade and settlement being one on the blockchain provides the ability to facilitate, cross-border trading and settlement without having lots of costs for transacting. And I think that's very important for multinational companies that have a lot of sites all around the world in different jurisdictions and are trying to cover their energy needs, from multiple different sources. So I think that there's a lot of problems in electricity markets that technologies supported by the blockchain can assist in managing that energy transition and the disruption that is occurring, but without as much destruction of value.
Okay, thank you. Thank you very much, Jemma. I would like to introduce you some of the questions we are receiving from the audience, okay? I'm open to any of you to take the lead to answer any of these questions, okay? So one first question, okay, it says that they are private. So how do you see blockchain being different than well-designed cloud software as a service software solution, okay? Which is the difference, because at the end they say that as being private blockchains, this is the same as having a cloud solution well-designed. Which is your view? I don't know who of you wants to take the lead for answering this. Christoph, you want?
I'm happy to comment, and I think one of the elements, and I've made that point before. I think one of the elements, by the way, we think it's a very important question. If you look at cell phones as the example, that is managed through existing technologies, but it comes exactly back to the question: who is in charge of the identity of the cell phone? It's this self-sovereign identity management that the cloud system today does not provide, and with the blockchain that simply becomes possible, and therefore questions like, is this public or private, suddenly become less relevant. Regulators can enable the consumer to be in charge of their own identity if that is needed, and that is, I think, a very critical difference of a blockchain technology versus a traditional cloud type of technology.
Okay, thank you very much. They say that maybe another view, Christoph, they are suggesting that maybe
Sabina wants to come in.
Okay, sorry, Sabine, sorry.
I'm very passionate about the whole private and public story, so I'd love to get some more perspectives in. I think, just to maybe give a perspective on the evolution, I think of different technologies and also blockchain. It makes sense that at the start of such a new technology, which is, let's say, the next wave of computation, which is entering our world today, that you have still at the start, at the nascent phase, more private enabled technologies, because people are careful. Companies need to get used to it. You need to connect and define governance in a completely different way. But how I see it personally, I think you have a clear shift already today where you're starting to shift from more private networks to much more public blockchain permissioned networks. And I think that is going to be such a fundamental thing. I don't think we'll all get there overnight, but I think really in a number of years' time, we will see a capability unleash where you have this open available infrastructure network, which is public, where these decentralized identities can join or companies can easily transact on without having built all these new private blockchains around the world in private consortiums, because I think over time you could face potentially issues in terms of scalability or interruptibility there. So I'm really looking forward to that shift. I think it's going to be an exciting one. And yeah, I would encourage a lot of companies and also individuals to start testing out with the prospect of looking at more public networks instead of private.
Yeah, that is what a very good answer. Is the person who was making this even suggesting that maybe the public blockchain, the real difference between a cloud solution and the blockchain technology would be to be more public blockchain. So that's good. Another question that we have from the audience. It says that, and it's a really conflict question. It says that blockchain energy efficiency. So how we can use blockchain for decarbonization if blockchain is inefficient in the energy use? So it's a hard question. Okay, I don't know who wants to answer to this.
It's not a hard question, but let's have Sabina have a go at it first.
Okay. So excited to take this one. Yeah, maybe just to share, I get asked this question a lot. So I think it's also a really important one to answer and also change the perception of blockchain in the energy industry on this, because where that whole comes from about the energy efficiency and that, we all think about Bitcoin and that it uses large amounts of energy to form consensus within the network layer, the type of consensus mechanism used, which is called proof of work. This requires a large amount of energy to protect and to allow for the miners within the network to finalize and complete the puzzles in order to confirm the transactions and post those to the network. And in a proof of work where you don't have that centralized component or any intermediary being placed, you need a high secure consensus mechanism for this network of miners to form this. That is just one example, though. There are many different types of examples of how blockchains are architected in such a ways that you do not require such high energy intensity to form that consensus within the network of these miners and nodes. So there's different forms of architecting this. Another one could be proof of authority as an example. These are different consensus mechanisms where you rather rely on the authorities within the network in a round-robin kind of fashion to form that consensus. And that does not require you to form as much energy. So yes, Bitcoin today does use a large amount of energy, but that is the first sort of generation of public blockchains out there. And it's really dependent on the way you architect these systems. And there are many different alternatives that provide low energy solutions. So it's a really important cornerstone. Anything you'd like to add, Christoph? I know you were Decided to answer
It's hard
this
to
question.
add. It's hard to add. You said it exactly, Sabina. I think when we started with the Energy Web Foundation, it was one of the criteria that if we do it for the energy industry, it must be aligned with ultimate energy sustainability criteria, and that means it cannot be an energy consumer by itself to the extent that we see in Ethereum or Bitcoin. So we have built a blockchain without the mining part, without the proof of work consensus mechanism, with the proof of authority mechanism. And that, so just in comparison, the Energy Web blockchain consumes about as much as a light bulb, and not as much as would be produced by a large power plant, or many large power plants, by the way. And this is an entirely different way of doing it. Again, it keeps the blockchain aspects intact and does not require the energy. So it's working today. It's by no means any theoretical kind of statement. It's what we have brought to reality actually with the Energy Web chain.
Thank you, Jemma. Do you want to add any? No. Okay. Another question from Jemma.
Another question. I'm ready.
Okay. Someone from the audience asked us how we can imagine using blockchain for carbon capture use and storage and the energy emissions trading system. How we can see or vision how blockchain can really help in these two aspects. Okay. I don't know if one of you want to talk about carbon capture and use.
I mean, they're two quite distinct topics. I think on the topic of emissions trading, we're really talking about like carbon attributes or environmental attributes, and carbon credits and renewable energy certificates can readily be tokenized using blockchain and smart contracting functionality, and that are able to be ubiquitous but also have specific identifiers in them. So, where and when a credit was originated from. So you might get, a generic certificate, but it actually has quite a lot of unique identifying attributes in it, and it could be readily traded. So I think that carbon credits and emissions trading schemes, I think, are going to, perfect use cases for the blockchain. And in a lot of countries that perhaps have a carbon tax right now, but are moving to emissions trading schemes, renewable energy certificates may instead be traded as carbon credits. And so the ability to flex between those two types of environmental commodities, I think, is something that we'll probably start seeing, depending on what the prices are being traded for each of those two in any particular market, and that the tokens could be readily traded and settled, on a digital currency exchange. In terms of carbon capture and storage, I mean, a lot has been said about carbon capture and storage. There were lots of estimates about how much carbon could be captured, but volumetric. I think JP Morgan put out a report with Václav Smil last year, which is really interesting on the topic. The actual sheer volume of space is very large, and what was estimated as a really big growth sector has actually not manifested to be a material source of carbon sequestration. So I think that the sector, if it's going to reach potential, is going to need to do a lot more than it has done to achieve its ambitions. But and I think that the longevity of the sequestration of the carbon is still yet to be fully understood and known. So I think the two distinct topics, I would say the carbon credit side of things is a natural kind of use case for blockchain, and carbon capture and storage I'm not sure about.
Okay, thank you, Sabine. Do you want to complement or to add anything?
Yeah, maybe just the example on that one element, just to complement what Jemma has mentioned and what I mentioned earlier, is I think anything with regarding to especially carbon emissions forming that traceability. I think it's absolutely essential that we have not just blockchain, but these open accounting mechanisms that are transparent and traceable, that able to manage these multi-party actions and coordinations and data exchanges. And I think that is the core to these kind of carbon credit schemes, any emissions recording. It forms, again, very eloquently with the attributes or the benefits of what blockchain can bring as an open shared infrastructure to manage that large inventory actually and record system for emissions and any carbon credits. So I think that's the most to be said about it at this moment. That I just see a large potential in that space for us to move forward to these common goals of decarbonization and using avoidance reduction as much as possible, and using these fair open accounting systems to achieve that common goal of decarbonization. And blockchain fits very nicely to be able to facilitate that.
Okay, thank you, Christoph. Any comment? Additional comment?
No, it's hard to add. I think Jemma and Sabine have made the points well. I think one is the technology question, and I think it's not the panel to talk about technology, but I would agree with Jemma. The 35 gigatons is just an unimaginable amount, and it's important to think about how we can sequester a portion of that, but we with it is probably dangerous. And while we should do it, while we should start by small step, I think blockchain is indeed the place where we can tokenize and make progress in making sure that what is actually done is not sold multiple times, and therefore the blockchain has to play to it. But I think that's exactly what Jemma and Sabine have said as well. So not much to add.
Okay, thank you very much, Christoph. Other question that comes from the audience. Okay, it says that one of the challenges of blockchain is the privacy of the parties participating in the blockchain. Okay? So, which solutions can we use to solve the privacy issue that can have any party that want to participate in a blockchain network? Who wants to take this question?
I'm happy to.
I can have please, Sabina, go.
Okay, Sabine, go.
Yeah, I'm sure. I'll keep it brief. I think when the whole notion of blockchain, and when we look at the core properties, and especially with people just getting acquainted with it, you'll obviously think, transparency and the public nature of a blockchain exposes everyone's data. How do you transact with other companies, and make it all transparent? You maybe not want to share all the data, or data could be commercially sensitive, for example. And I think this was a core sort of issue that was discovered or looked at into blockchain early days already, to try and overcome this, because it's a clear need for blockchain-enabled systems to be able to facilitate transactions where privacy is not compromised. And for any enterprise blockchain adoption or any consumer adoption of blockchain, I think this is a core trait. So what we've seen over the last couple of years is a lot of innovation and a lot of strides have been made to ensure that private transactions are possible on a public and a private blockchain. So again, it's the way you architect it, it's the way that you use new innovations on a blockchain to allow for two companies, let's say, to transact over a network, only disclose that certain information between those two without exposing all that information to the rest of the network. And without getting too technical, I think that's a core attribute and core trait for people to understand that, yes, there are solutions available today that allow for these transactions to happen without exposing or removing the need for privacy. It's really how you design the type of applications that you build on top of these networks.
Okay, thank you very much. Very good. Any other comment regarding the privacy issue?
Perhaps only just one slight addition to that. I obviously would subscribe to everything that Sabina said, and that many blockchains today have solutions to deal with exactly those types of issues. I do believe, however, that for regulators, a lot of if you're in a public goods space or in what is perceived this emission certification or so, that's close to public goods space. But then if you are a critical infrastructure space, and that's obviously in the energy space the case, then regulators will want to have a deep understanding of what's actually going on. And beyond the public that many blockchains can facilitate, it's very important to think about how open source an approach can be. And I think for regulators to be able to verify that they agree with the mechanisms behind the systems, and that doesn't mean they can see every single transaction, but they can see mechanisms of those transactions is another very important aspect. And I think that's perhaps the one addition I would make to what believe that, and when I say we this time, again, it's an Energy Web Foundation, that this open source aspect is absolutely critical when it comes to the public or critical infrastructure aspects, and they are in the long term, it's plausible we see more of open source solutions breaking through others.
Okay, Jemma, do you want to add anything more?
I think that given the regulatory changes that have occurred in different markets, I think 2021 is going to be very exciting for the blockchain. Across flexibilities, markets are really going to be driven into existence in a big way. I think this year that there is a big shift from carbon tax to emissions trading schemes, so market mechanisms that, as I mentioned, is a natural use case for tokenization of these environmental commodities. Energy trading regulation is really being supported in Europe in a very big way with the implementation of the Clean Energy Act, and I think countries like France and Austria will lead the way in that respect. And deregulated markets in the US, as well as just more broadly implementing FERC 2222 rule change. So I think that these things are all kind of coalescing to the regulatory settings that are going to sort of turn on the market, in the bigger sense of the word. So I think it's going to be a very exciting time for blockchain, and it's moment to start, I think, bring it to life, I think, as Christoph said at the beginning.
Okay, thank you. Another question that comes from the audience is they have listened a lot about involving the consumer, electricity markets, trading, all this kind of stuff. But they ask our opinion regarding, from your point of view, which would be the main initiatives that will make blockchain contribute to the carbon reduction. They are a little bit agnostic regarding that blockchain can contribute to carbon reduction. Okay, so
like from an additionality perspective. Sorry, Felipe, the line's just sort of cutting out a little bit between words that you're saying, but I think that if you're just replacing like an existing system with a blockchain solution, I think it's supporting a certain amount of carbon reduction, but it's not necessarily creating that concept of additionality. Where I think it can support carbon reduction is where the price signal that is generated by the blockchain is resulting in new assets being installed or existing assets being greater utilised. And so I think they're supporting decarbonisation efforts and reduction in emissions that would not have otherwise occurred. So if you get a price signal, if you don't have a price signal, a household might put a battery supply. But if they can participate in a virtual power plant, instead of putting in a 6 kilowatt hour system, they might put in a 15 kilowatt hour system and stabilize the grid and disrupt some coal-fired power station or gas-fired power station that's providing peaking services. So I think that the price signal could support decarbonisation efforts that would not have otherwise occurred. So I think that there is there is a great potential for it, but it's kind of the technologies along with the regulatory piece that allows this to occur. If households are locked out of being able to participate in virtual power plants, then that's not going to happen. So, or it might just be for commercial industrial customers, and they represent only half of the energy consumption in a grid. So you're getting half of the decarbonisation potential. So I think that the regulatory signals are as important as the technology that can make it a reality.
I think just to add to that, just to add to those points, perhaps the other, additional solutions will be able to bring new supply elements, crowdfunding being one of those. Blockchain-enabled crowdfunding could bring new assets into the game that otherwise would not be. But then also the fact that, again, if you say the transition is as fast as we manage to flexibilize the system, clearly this is part of flexibilizing the overall system, which then enables many more, renewable supply, intermittent supply solutions to actually be effectively be part of the system, and curtailment will be smaller. And that in itself is curtailment being what you cannot use at the time when it's produced. For instance, if the sun is shining and you just cannot consume things immediately, then that curtailed energy is simply lost. But if you manage to say additional flexibility to bring in additional load at that moment, or to bring in additional storage that otherwise you could not bring it at that moment, then you again have saved actually, or have managed to save carbon. And so there's a flexibilization, one additional crowd funding solutions, but then the whole price and market aspects that Jemma has mentioned, I think, are very important parts of the carbon play here.
Yeah, maybe even just one more perspective. Maybe this is such a packed question and a very important one. I think just to offer a different perspective here, I think if we're looking at the core properties of blockchain and decentralized tech, it's a decentralized technology with a sort of game theoretical incentivization layer on top of it. And the magic of what this technology can do is it can bring parties together that all have a, let's say, common shared incentive, a common goal. But you might come from different areas of the market, you might have different roles within those markets. And I think especially why this is such a paradigm shift of what blockchain can bring in the forms of additionality, in forms of reducing emissions at the end of the day, is that it instills new types of collaborations across industry to really think of those innovative new solutions for decarbonization and low carbon sources. So by enabling these kind of incentivization systems, open, verifiable, I think you can also unlock the potential for different types of investment structures for future decarbonization solutions that maybe today are hard to create a business case for, or hard to finance from this point of view, but in future that we can unlock. Just as an example, imagine where you can do fractionalized ownership of large assets around the world, or producing different types of low carbon solutions that as a company alone you might not venture down on. Not to say that that doesn't happen today, but I think blockchain just gives us that extra technology that enables that kind of collaboration, incentivization across the sector.
Okay, thank you, Sabine. Another question. This question is very practical. Okay, it's a use case. Some person of the audience is saying that they are making a district heating infrastructure. Okay, that this infrastructure will require to manage trading between the industrial heat suppliers and the heat retailers, and they asking you if blockchain could be a good technological solution to facilitate the trading and all the balancing functions that will be needed. I don't know, Jemma, do you want to answer this question?
Yeah, so when you talk about all the balancing functions that are needed, you're talking about in the grid?
Yes, in the grid. It's a district heating infrastructure, and they want to make it open, to be open to participate, and they will have heat suppliers, industrial heat suppliers, and heat retailers, okay? So they want to make the trading of these parties, and they want to know if blockchain could be a good solution for solving this.
Did you say heat suppliers?
Heat.
Heat.
A-E-A-T, heat.
So I think that, I mean, there's many different services that are provided by sort of traditional power supply. Things like inertia isn't necessarily even valued by, in the system. It's just something that's always been there. But we may need to start looking at things like synthetic inertia if, the conventional power systems that have provided that are, being retired. Then you've got, frequency control and ancillary services, and then more recently, alternatives to augmenting the grid. So instead of putting in capacitor banks, maybe, to deal with like a peak issue or a congestion issue, you might instead operate a market to, take surplus electricity or deal with congestion that might occur and avoid the need to augment the grid. So I think some things are known as known services like ancillary services, frequency control services. But others I think are new that are going to be required in the next few years more greatly as the energy transition unfolds and as countries and regions start implementing bigger targets around renewable energy. So I think that there needs to be an evolution of the market mechanisms that are going to encourage users to provide these services to the grid and to stabilise it. Otherwise, you'll be ending up with a situation where you probably have grid batteries that are providing these services, but they could have actually been provided by third parties that are invested in this kind of infrastructure, and you end up overall with like a higher cost system. And I think that although there is a lot of ambition around getting to 100% renewables, the cost of doing the last mile is very significant, and storage has to be a big part of that solution. So in the US right now, I think 1% of electricity is stored. It's very small. And, to have a battery big enough to deal with seasonal variation is going to be very costly. So I think that there'll need to be large-scale storage solutions put into the energy system as well. So things like pumped hydro storage, conventional like dams, as well as hydrogen. But hydrogen forecasts that it's not really going to make a meaningful impact on energy until like around 2040. So I think that the idea that we're just going to have lots of little household batteries and C&I batteries, I personally don't ascribe to that as the ultimate outcome. I think you will need a combination of conventional sources of energy and as well as new energy sources too. And you're going to need a combination of market mechanisms to get the lowest cost outcome and deliver the system stability that's required. So I think that there's no way you can Google to get the answer for this stuff, and a lot of the work that we're doing is really to get an understanding of what is going to work and learn from the mistakes of other the countries that have perhaps been at the leading edge, but ended up with a lot of renewables, but other challenges around cost and system stability.
Okay. So for finishing, okay, as district is really another market. Okay, trading is a common characteristic that blockchain can solve. So district heating issues could be with using blockchain technologies, a clear use case that could be really solved with this technology. For finishing I would like 1 minute for each of you. Okay, regarding your vision on how 2021 could be in the evolution of blockchain technology into the energy sector. Okay, only 1 minute for it. So Sabine, do you want to start?
Of course, picking me. I have less time to think about it. Very thanks. No, happy to. I mean, as Shell, we have large ambitions to accelerate the energy transition, and we see that blockchain is one of the key enablers and supporting mechanisms to accelerate that and support that energy transition. So my hope for 2021 is that we further the progress within the energy industry as a whole to adopt this. I really would like, not just within Shell, but just generally within the energy industry, let's stop doing things in silos. Let's stop experimenting within the boundaries of a company just to get the proof points. Now is really the time to go out and get the production systems live and get them enrolled and really get the hands dirty of people and of making sure we get that hands-on experience in collaborating across countries and implementing these kind of solutions. So I look forward to many of the collaborations we've got planned for this year, but also invite any new ones that maybe I have not thought about yet. So opening that invitation to everyone out there, and I'm really looking forward to accelerating the adoption this year.
Thank you very much, Christoph.
Yeah, I think it's really a time where we see the energy transition efforts being dramatically accelerated, and I think the best proof of that, at least from the sound bites, is the number of net zero commitments we get at this stage. And I think again, if those are to become true, all those commitments are to become true, we need not only to think about the supply side, we need about the system flex side. And system flexibility comes with providing identities to all those assets and making sure they get real life. So it's absolutely critical that we enable the system to become more flexible. And 2020, shall be the year where we see real asset applications to become numerous in the blockchain space, and therefore the scale up after that becoming a reality. So 2021 shall be the year of real asset applications in small scale first, but then with opportunity to scale.
Thank you very much.
I think that things like energy trading, peer-to-peer trading is like what brought the conversation around blockchain, into the fore, I think, around 2015, 2016. But this conversation really shows the evolution around the conceptualization of how blockchain can be used in the context of energy and electricity markets. So it's very broad, from asset ownership to environmental commodities, trading of energy, trading of services, and flexibility services. And I think there's a lot of use cases that are being trialed and experimented. And I concur with my fellow panelists that this year is going to be very exciting. And on the topic of heat, I thought you were talking about like thermal inertia, but I think you may have also been asking a question around the district heating and cooling. And on that topic, I would say that the measurement and output of services from heating systems could easily be tracked on the blockchain, no different to any other kind of utility service like water or electricity or gas for that matter. So I think that is an area in cold climates where those kinds of services are implemented at the district level. It could also be a natural use case for the blockchain.
Thank you very much, all of you. Thank you very much for the audience. I hope that has been an interesting debate with all the panelists. My main things that comes to my mind from what we have been talking about is that thing can be scaled. This year would be a year when we can go from pilots to real scale solution. The blockchain can contribute to the carbon reduction, and that making that many renewable energy will really and will be more used than without this technology. Thank you very much to all of you, and I hope you have a rest of the day. Bye bye.
Thank you.
Bye-bye.